What if the next technological revolution took place beyond our atmosphere? With its supercomputer satellites, China is redefining the rules of the digital game by focusing on the stars. The race for innovation has never been more electrifying, and this time the playground extends to the depths of space. China, with its bold bet on supercomputer satellites, is carving out a new frontier in the digital universe. These technological wonders, boldly floating beyond our atmosphere, could well be the pioneers of a new era. Welcome to the future of technology, where the stars are no longer just bright points in the night sky, but hosts of revolutionary potential, a computer revolution starting in space. Computing and the internet are now at the heart of our daily lives. Every video watched, every search made, or every online transaction relies on massive infrastructures, data centers. However, with the meteoric rise of artificial intelligence and the exponential demand for computing power, earthly limitations are beginning to be felt. It is in this context that China, with its visionary project led by ADA Space, has decided to aim higher, literally. Their ambition, to deploy a fleet of 12 satellites equipped with supercomputers in space to form an exceptional computing constellation. Satellites unlike any other, the recent launch by the Long March 2D rocket marked a decisive advance. These 12 satellites placed in low orbit not only collect data or ensure communications. They carry systems capable of achieving unmatched performance, peta operations per second. This far surpasses the capacities of traditional data centers on Earth. But this initiative is only just beginning. Ada Space eventually plans to deploy a constellation of 2,800 interconnected satellites via laser communications. This revolutionary technology will enable fast and efficient data transmission while ensuring increased resilience against earthly challenges. Natural cooling and reduced carbon footprint space is not only a field of technological innovation, it also offers solutions to environmental challenges. One of the main problems of terrestrial data centers is their massive energy consumption, mainly related to server cooling. In the vacuum of space, this constraint disappears as satellites benefit from natural cooling. This characteristic significantly reduces the carbon footprint of digital infrastructures. Furthermore, by overcoming earthly limitations, these satellites help reduce the pressure on already limited resources while paving the way for a more sustainable and environmentally friendly computing, ahead in the race for space infrastructures. With this project, China is establishing itself as a major player in the revolution of computing infrastructures. The goal is twofold: to support the growing needs of artificial intelligence and to ensure the country's strategic autonomy in key sectors. According to Jonathan McDowell, an astrophysicist at Harvard, this initiative could encourage other powers, such as the United States or the European Union, to develop similar projects. Such a deployment could transform space into a true extension of our digital infrastructures. Imagine a planet where data circulates between satellite constellations rather than in undersea cables or terrestrial data centers. This vision is no longer science fiction, but a tangible perspective. Dizzying prospects for our connected future. If China succeeds in realizing its ambitions, this breakthrough will deeply redefine the global digital landscape. But this technological race also raises questions. What will be the geopolitical implications? What regulations will need to be put in place to prevent space saturation or conflicts of interest? Humanity is on the cusp of a new chapter where the stars will no longer be simply admired, but exploited. By betting on innovative space technologies, we are opening a path towards a future where space plays a central role in global connectivity and data management.